Welcome to the Deep Dive. Today we're tackling a really interesting piece of research focused on this growing area, autonomous AI agents. You know, the ones that can navigate the web and act for us.
Right.
And the crucial question this paper brings up is all about privacy. How do we make sure these helpful agents aren't accidentally exposing our sensitive personal info while they're just trying to do their jobs?
Exactly. And this paper introduces a new benchmark they're calling AgentDAM, short for Agent Data Minimization.
Okay.
Think of it as a way to test how well these AI agents stick to the rule of only using and sharing the private data that's absolutely necessary for whatever task they've been given.
Data minimization, got it.
Yeah, it's all about preventing those unintentional data leaks, even if the information is technically accessible to the AI, you know.
Okay, let's maybe unpack this a bit. Why is this suddenly such a hot topic in machine learning research right now? We've had AI helping online for ages. What's the big shift with these autonomous web agents?
Well, the key difference really is the level of independence. Older AI systems, they usually need very specific instructions, like at every single step.
Right.
These newer agents, they're designed to take a much higher level goal, like say, book me a flight to London next Tuesday, and then figure out on their own how to navigate websites, fill out the forms, complete the booking.
All by themselves.
Exactly. And to do that effectively, they often need access to quite a lot of user data, maybe emails for travel preferences, calendar details, even browsing history, perhaps.
Yeah.
The concern and what this paper investigates is that even if booking that flight only needs a date and destination, the agent might inadvertently process or even, reveal other sensitive stuff it has access to.
So it's less about the AI having like bad intentions.
Right.
And more about it potentially not understanding or respecting those sort of unspoken privacy boundaries. The researchers mentioned this, didn't they? That even really advanced language models can struggle with knowing what's private in a specific situation.
Precisely. Yeah, they reference other studies showing that even state-of-the-art models like GPT-4 can have trouble figuring out what information is okay to share in different contexts.
Okay.
So now, when you give these models the ability to basically roam freely on the web and take actions autonomously, the risk of accidentally leaking private data just becomes much, much higher.
Makes sense.
And this AgentDAM benchmark is their attempt to put a systematic framework around evaluating the specific risk.
All right, so AgentDAM is the measuring stick here. How exactly does this benchmark work then? What kind of tests are these autonomous agents put through?
So the benchmark uses this realistic web interaction simulator called Visual Web Arena.
Okay.
And the researchers created a data set of, I think it was 246 carefully designed test cases across 3 common types of websites: Reddit, GitLab, and online shopping platforms.
Pretty standard stuff.
Yeah, and these tasks are deliberately set up so that the AI agent gets both the information it needs to complete the task and also some irrelevant private information that it should ideally just completely ignore.
Okay, can you give us maybe a concrete example just to really illustrate how that works?
Sure, yeah. Imagine you ask the agent to post a comment on a GitLab issue, maybe based on some notes you've jotted down in a Google Doc about, let's say, Project Alpha.
Right.
Now, this Google Doc might also contain, your private health information or maybe login details for your bank account stuff that has absolutely nothing to do with commenting on that GitLab issue.
Gotcha. Total mismatch.
Exactly. And the benchmark then watches the agent's actions, what it types, what it clicks, what it submits, to see if any of that irrelevant, sensitive data ends up being included in its output, like in the comment text.
Okay, I get it. So it's not just about whether the task gets done correctly, but the whole process, what the paper calls the trajectory of actions.
That's right.
And how do they actually spot these privacy leaks? Are they like manually reviewing everything the AI does? That sounds tedious.
Yeah, that would be incredibly time-consuming and, not very scalable. So instead, they developed what they call an LLM as a judge module.
Interesting name.
It is, and it cleverly uses the reasoning abilities of GPT-4 in this case, using a technique called chain of thought prompting.
We've talked about that before.
We have. So this LLM judge analyzes each action the web agent takes and determines if any of the pre-identified sensitive data has been exposed. It's pretty straightforward. Yes or no. A leak happened or it didn't.
A binary thing.
Exactly. And from this binary scoring, they can then calculate an overall privacy leakage rate and, conversely, a privacy performance score for the agent being tested.
That's a really innovative approach, using one powerful LLM to essentially audit the privacy behavior of other AI systems. So what kinds of readily available AI agent setups do they evaluate using AgentDAM?
They looked at two main categories of systems, things that are either available now or are based on, well-established architectures. First, they tested web agents adapted from existing benchmarks like Web Arena and Visual Web Arena. These usually have an LLM or maybe a vision language model that's a model that can process both text and images at their core, and they look at representations of the web page to decide what to do next.
Right.
Second, they evaluated these computer use agents from Anthropic, specifically their Claude Sonnet model. These agents are designed more broadly to interact with a full desktop environment just by looking at screenshots.
And how are these web pages actually presented to the AI agents? Is it just the visual information, the screenshots they see?
Well, they primarily use two different ways to represent the web page. One is the accessibility tree, often called AX tree.
AX tree, okay.
Yeah, it's a structured text-based representation of all the elements on a web page, organized hierarchically. Most text-based LLM agents can work with that kind of input. The other method is using a web page screenshot combined with something called set of marks prompting, or SOM.
SOM.
Right. With SOM, the interactive elements on the screenshot buttons, links, text fields are highlighted with bounding boxes and given unique IDs.
So it's visual plus labels.
Exactly. This multimodal approach lets agents that can see understand the visual layout and identify those interactive elements. Though, interestingly, the Claude Sonnet agent they tested only works with plain screenshots. No SOM for that one.
Okay, so just to recap the setup. The agent gets a user instruction, some kind of representation of the web page, text or visual, and this user data that might contain both necessary and unnecessary private bits.
Correct.
It then takes an action, and that action gets checked for privacy leaks by this LLM judge. That makes perfect sense as a testing framework. Now, where do they get this user data with the embedded sensitive information for their experiments? Do they make it all up?
This is actually a really critical and I think well-designed part of their method. They created a data generation pipeline. It starts with human annotated data seeds.
Data seeds?
Yeah. Each seed has two key parts. A phylogeny, which describes the relevant information needed for a particular task.
Okay.
And sensitive data, which lists the private details that are irrelevant and definitely shouldn't be exposed.
Got it. Plot is good. Sensitive data is bad.
Essentially, yes. Then they used a very powerful language model, Llama 3.170B, to generate realistic-looking user data, things like chat logs, emails, documents, by sort of naturally weaving these sensitive data into the context provided by the PLRT.
Clever. So it looks natural.
Exactly. And to make their evaluation more robust, they generated two unique examples of user data for each single data seed.
That's a really smart way to create a controlled but still fairly realistic testing ground. And when they actually evaluate how well an agent does, it's not just about privacy, is it? They also look at whether it successfully completes the task.
Exactly, yeah. They have two main evaluation metrics, two axes. The first is utility or task performance. This is measured by a reward function that checks if the agent successfully achieved the intended goal. Did it actually post a comment on Reddit, add the item to the shopping cart, whatever the task was?
Success or failure.
Right. The second, as we've been discussing, is privacy performance. This is based on that privacy leakage rate detected by the LLM as a judge, specifically looking for any appearance of the defined sensitive data in the agent's actions.
Okay, so we have the benchmark, the agents being tested, and the metrics for success and privacy. Now, what were the key findings when they put all this together and ran the experiments? What did AgentDAM actually tell us about the current state of privacy in these autonomous web agents?
Well, the results were quite eye-opening, I'd say. Across the board, they found that the models they tested do indeed exhibit privacy leakages. The rates ranged from about 10% up to, in some cases, as high as 46%.
Wow, nearly half the time for some.
Yeah, that means even the better performing models were still frequently exposing private data. Interestingly, though, they observed that the Llama and Claude models showed a slightly better initial level of privacy awareness compared to the GPT models, even before they tried any specific techniques to improve privacy.
Any idea why?
The paper doesn't speculate too deeply, but it suggests maybe different training data or architectural choices might play a role.
Okay. And did the way the web page was presented, just text from the accessibility tree versus the visual info from screenshots, did that have a big impact on these results?
They found that using multimodal inputs, so the screenshots with set of marks, generally led to a slight improvement in task performance.
Makes sense. More info.
Right. It makes sense. Intuitively, the agent has more information about the web page layout to work with. However, it didn't seem to have a really significant or consistent effect on privacy performance.
Interesting.
Yeah, it suggests that simply giving the agent more visual context doesn't automatically make it more careful about handling private information.
The paper also explores some strategies to try and mitigate these privacy leaks, right? What did they try, and how well did those efforts work?
They focused on two prompting-based strategies. The first was what they called a privacy-aware system prompt that they gave to the agent, combined with examples of how to behave responsibly, what they call chain-of-thought demonstrations.
So basically telling it to be careful and showing it how.
Pretty much, yeah. They explicitly told the agent, hey, be mindful of irrelevant private information that might be present in the user data, and showed it examples of how to avoid using it.
And did it work?
Actually, yeah, this approach turned out to be quite effective. It significantly improved the privacy performance across all the models they tested. In some cases, it brought the privacy performance metric up to 94%.
That's a big jump.
It is, but there was often a slight downside, a decrease in task performance.
The trade-off.
Exactly. Sometimes the agent would become maybe overly cautious and refuse to perform legitimate actions. They called these false denials.
So it got too scared to act sometimes. And what was the second privacy-enhancing technique they explored?
The second approach was to try and pre-filter the user data before it was even given to the agent. They used GPT-4 again, this time, to try and identify and remove any information that seemed irrelevant to the task at hand. Basically, trying to do the data minimization up front.
Like cleaning the input first.
Right. They found, however, that this pre-filtering method was generally less effective than directly using that privacy-aware system prompt with the demonstrations.
Okay, so it sounds like carefully instructing the agent about privacy through prompting is the more promising immediate solution, even if it might sometimes make the agent a little too cautious.
That seems to be the takeaway from their mitigation experiments, yes.
Where were these privacy leaks most likely to happen? Were there certain types of tasks that were particularly problematic?
Yeah, their analysis of the patterns showed that the models were most likely to leak sensitive data in tasks involving generating longer, free-form text outputs.
Like writing stuff.
Exactly. Think about crafting Reddit posts, filling out detailed contact forms, or writing lengthy comments on an issue tracker like GitLab. These kinds of tasks naturally require the agent to process and generate more text, which just increases the opportunities for inadvertently including sensitive information that it shouldn't.
Makes sense. More words, more risk.
Right. The Reddit create post task, for instance, showed the highest frequency of leakage in their tests.
That makes intuitive sense. The more the agent has to say, the higher the chance of a slip-up, I suppose. Did they notice any common themes in the types of sensitive information that ended up being leaked? Like, was it always financial data or?
They gave one specific example, which was quite telling. An agent was tasked with commenting on a GitLab merge request based on a Slack conversation.
Okay.
But it mistakenly included an irrelevant detail from that Slack chat about a colleague's upcoming absence for a religious holiday in its GitLab comment.
Oh, wow. Completely unrelated.
Totally unrelated. But it really highlights how easily contextual information, even if it's not directly related to the core task, can be picked up and then sort of spread by the agent in an inappropriate context.
Yeah, it's a subtle but important kind of leak. It's also interesting that they looked at whether different AI models tend to make privacy mistakes on the same kinds of tasks or with the same types of sensitive information. What did they find when they compared the different models' failure patterns?
That was interesting. Their analysis, using something called Pearson correlation, suggested that for the most part, different families of models, like, say, the GPT models versus the Llama models, tended to leak different types of sensitive information and often on different tasks.
So they fail differently.
Generally, yes. The main exception was within the same family of models, like comparing GPT-4 to GPT-3.5. Those showed a higher degree of similarity in their privacy failure patterns. But comparing across families, the correlation was low. This kind of hints that the underlying architecture, or perhaps the specific data these models were trained on, might lead to different inherent strengths and weaknesses when it comes to preserving privacy. They don't all fail in the same way.
This research certainly paints a picture of the current challenges, but it also really underscores how crucial this kind of rigorous academic evaluation is. So maybe let's step back and look at the bigger picture for a moment. What's the history in machine learning that has led us to this point, where we're building these autonomous web agents and now grappling with these specific privacy concerns?
Well, the development of these autonomous AI agents is really a kind of a natural progression. It's driven by the just rapidly increasing capabilities of large language models.
Right, the LLM explosion.
Exactly. Over the past few years, we've seen LLMs evolve from just doing basic text generation and maybe information retrieval to being able to use external tools, follow increasingly complex instructions. The logical next step in that evolution is to give these models the autonomy to perform entire tasks for us on the web. Booking trips, managing emails, online shopping, you name it. However, the significant increase in autonomy has, quite rightly, raised important questions about AI safety in general. And privacy is obviously a fundamental aspect of that broader safety discussion.
So AgentDAM isn't coming out of a vacuum then. Were there other academic efforts to benchmark privacy specifically in AI agents before this particular work?
Yes. Absolutely. The researchers discuss a couple of related works in the paper. One is called Confade.
Confade?
Yeah, Confade. It focused on evaluating how well language models can reason about privacy, but specifically in the context of a purely text-based chatbot interaction.
Okay, just text.
Right. Another one is Privacy Lens, which also created a privacy-aware data set and tested the sequences of actions taken by agents. But again, it did so in a simulated text-only environment.
So more abstract environment.
Exactly. AgentDAM really stands out because it focuses on a more realistic web environment, one where the agents interact with actual website structures, visual layouts sometimes, and perform a diverse set of tasks that require genuine web navigation. To the best of their knowledge, this is the first benchmark to specifically address this challenge in such a realistic, multimodal setting.
And how does this work on privacy in autonomous agents relate to the maybe more established body of academic research on LLM privacy? Things like concerns about models memorizing training data or the risks of prompt injection attacks.
Yeah, that's a really important distinction to make. A significant amount of existing research on LLM privacy has focused on whether models might inadvertently recall information from their training data.
Right, regurgitating things they saw during training.
Exactly. Things like membership inference attacks. Can you tell if a specific person's data was in the training set? Or the extraction of specific training examples? There's also a field called contextual integrity, which looks more broadly at whether the flow of information feels appropriate or inappropriate within different social contexts.
Okay.
AgentDAM's focus is quite specific. It's looking at privacy leakage that happens during inference time. That is, when the agent is actively performing a task using user-provided data right now.
Not about the training data, but about the current interaction.
Concisely. And while things like prompt injection and other security vulnerabilities are definitely relevant concerns for AI agents too, AgentDAM provides a complementary lens. It's focused specifically on those unintentional privacy breaches that can occur even when the agent is just trying to follow instructions correctly.
Okay, that clarifies the specific niche this research fills. So, to really nail down the key academic contributions and insights from this deep dive into AgentDAM, especially for our listeners who follow machine learning research, what are the big takeaways?
Okay, let's summarize. Firstly, I think the study provides clear empirical evidence using a rigorous benchmark that current autonomous web agents are indeed susceptible to privacy leaks, even when they're simply trying to execute a specific user instruction.
Okay, point one. The problem is real and measured.
Right. This highlights a significant gap between the capabilities of these models in performing tasks and their ability to inherently safeguard user privacy. Secondly, the AgentDAM benchmark itself is a valuable contribution to the field.
The tool itself.
Exactly. It provides a standardized, realistic, and seemingly adaptable tool that researchers can use to systematically evaluate and compare the privacy performance of different AI agent architectures, different prompting strategies, specifically in these web-based scenarios.
Good for future research.
Definitely. Thirdly, their exploration of those simple prompting-based mitigation techniques, especially finding that privacy-aware system prompts can lead to substantial improvements, albeit with that potential trade-off in task accuracy, offers practical insights for developers, maybe even in the short term.
Practical advice.
Yeah. Fourthly, the observation that different families of AI models exhibit different patterns of privacy leakage is important. It suggests there are likely fundamental differences in how these models internally represent and reason about sensitive information.
They fail differently. hinting at deeper reasons.
Exactly. That's a key area for future research, understanding those underlying vulnerabilities better. And finally, the research really highlights that tasks involving free-form text generation pose a particularly significant challenge for ensuring data minimization in these autonomous agents.
The writing tasks are the riskiest.
Pretty much. It points to the need for more sophisticated techniques to manage information flow, especially in those scenarios.
These findings certainly have significant real-world implications as these technologies mature, but as you said, also provide valuable direction for future academic inquiry in the field of secure and privacy-preserving autonomous AI.
Agree.
All right, now for our Novel Notions segment. Based on this deep dive into AgentDAM and the ongoing challenges of privacy in autonomous web agents, what kind of potentially groundbreaking, maybe even a bit out there, research directions does this spark for you?
Okay. Well, considering this trend toward increasingly integrated AI agents in our lives, potentially managing very sensitive tasks based on highly personal data, one fascinating research direction, I think, is the idea of privacy adaptive agents.
Privacy adaptive agents. Tell me more.
Imagine agents that go beyond just static privacy instructions like the prompts they tested. Instead, they could dynamically adjust their behavior, maybe even how they process information, based on their own understanding of the sensitivity of the current task and the specific data they're interacting with right then.
Whoa, okay, that sounds incredibly advanced. How might that even be architected from a research perspective? What would that look like?
Well, it could involve exploring the integration of more formal privacy frameworks, perhaps drawing inspiration from concepts like differential privacy.
Which is usually about large data sets.
Right. But adapting those core ideas for the sequential decision-making process of an agent. So instead of just adding noise to data sets, maybe the agent could learn to make probabilistic decisions about whether to access, process, or output certain pieces of information based on some kind of learned or predefined sensitivity score and its relevance to the current goal.
Interesting. So the agent would have some kind of internal mechanism for assessing and managing privacy risks in real time on the fly.
That's the idea, yeah.
What kind of foundational research would be needed to even get close to supporting that kind of capability?
Well, on the more immediate and maybe obvious front, continued research into more sophisticated prompting techniques, methods for fine-tuning agents specifically for privacy, directly using benchmarks like AgentDAM to measure progress, that would all be essential groundwork.
Sure, building on what we have.
Right. But looking further out, maybe the non-obvious direction, I think it would be incredibly interesting to investigate applying advanced cryptographic techniques, things like homomorphic encryption or secure multi-party computation.
Whoa, okay, getting really technical now.
Yeah, but applying them within the context of web interactions managed by AI agents. Could an agent potentially process and act on sensitive data without ever fully accessing it in plain text, maybe even within the user's browser?
So it could work with encrypted data?
Potentially. Now, the computational overhead is a huge hurdle with current technologies, obviously. It might be too slow for real-time web stuff now.
Yeah.
But breakthroughs in making those techniques more efficient could be transformative. Imagine enabling truly secure and private online interactions mediated by AI. Now, think about managing financial transactions or accessing private medical records through an agent without ever seeing the raw data.
That's certainly pushing the boundaries. What's a potentially overlooked implication or challenge in developing these kind of privacy adaptive agent systems, assuming we could even build them?
I think we would need to fundamentally rethink how users interact with and understand these agents. If the agent is making complex adaptive decisions about privacy, users would need a high degree of transparency into how it's making those decisions.
Seeing under the hood a bit.
Exactly. And perhaps even the ability to define their own very granular privacy preferences, different rules for different types of data, different kinds of tasks. Imagine telling your agent, look, for all financial tasks, be extremely cautious about revealing any personally identifiable information, even indirectly, or maybe for research tasks, using anonymized data is fine, but never ever share my contact details.
User controls on steroids.
Kind of, yeah. This level of user control and visibility into the agent's internal privacy mechanisms would be absolutely crucial for building and maintaining trust, I think.
Fascinating. A future where AI agents are not just intelligent and autonomous, but also inherently privacy aware and adaptable to the specific context and sensitivity of the information they're handling. It sounds like a significant leap forward, but also a complex one.
It is, definitely. And as always with this segment, these are speculative research ideas intended to spark thought and discussion, not necessarily predictions of immediate technological breakthroughs.
Understood. Well, this deep dive into the AgentDAM paper has certainly illuminated a critical area of research at the intersection of autonomous AI agents and user privacy. It's clear that rigorous benchmarking and continued academic inquiry are essential if we want to ensure that these powerful new technologies can be developed and deployed in a way that respects and protects our sensitive information.
Absolutely. And it encourages all of us, I think, both researchers and the wider public, to think carefully about the privacy implications of the increasingly autonomous AI systems that will likely play a growing role in our digital lives. It's not just a technical problem.
Very true. For those of you in the audience who want to delve into the technical details of this specific work, we've included a link to the AgentDAM research paper in the show notes.
It's worth a read.
Definitely. And on that note, we leave you with this thought. As AI agents become more and more capable of acting on our behalf online, how can we ensure they evolve into truly trustworthy guardians of our digital privacy? Thanks for joining us for this deep dive.